ஆரம்பிங்க.
Okay. Good afternoon to all. I would like to, my name is Nalayan, lecturer tool and ID making department, Murugappa Operating College. I would like to discuss about topic about press tool. Since it is a vast topic, let us see the only fundamentals I would like to teach you today. First, let us see what is press working. Press working. What is press working? Before seeing the advantages, let us see what is press working. Press working may be defined as a chipless manufacturing process by which the various components are made from the sheet metal. Press working operation is carried out with the help of metal forming machine, which is called as press, which shears or forms the component by applying a force. Let us see the characteristics of press working process is the application of large force by a press tool for a short time interval, which results in cutting and deformation of material, which cuts and shears the material. It can be seen. Let us see what is the advantages of press working. First, it is a high productivity, a better accuracy, uniformity of parts are produced, possibilities of using lesser skilled labors, low scrap losses, reduction of weight, considerable cost reduction, possibility of automation. Now let us see the basic fundamentals of press tools operations. The press tool operations can be classified into two types. One is cutting operation, another one is non-cutting operation. In cutting operation, the workpiece is stressed beyond its ultimate strength, whereas in non-cutting operation, the workpiece is stressed beyond its elastic limit and within the ultimate strength. It's very simple to say that it ranges between the elastic region and a plastic region, whereas in cutting operation, it goes elastic region and plastic region, then it goes at deformations. There are various types of cutting operations. Just let us see blanking, piercing, trimming, shaving, notching, lancing, nipping, perforating, parting, and shearing. These operations can also be classified according to their various operations, just as operations for producing blank, operations for producing finishing component, like size control, like that way we can classify it. Let us see one by one. First, we'll see the operations for producing blank. For operation producing blanks are classified as blanking, shearing, and cutoff. First, let us see about what is blanking. In blanking operation, the cutting action must be completed or enclosed conduit. The entire periphery is cut. The cutout piece is called as a blank. In blanking operation, the entire periphery should be completely, it should be a closed one. The conduit should be a closed one and should be cut. The entire periphery is cut. In cutting operation, the sheet metal from which the blank is to be cut is properly located over the die and the punch is lowered into the to produce the required cut. So the blank strip sheet is placed in between the punch and the die. There will be a small amount of spring back which can be neglected in this blanking operation, whereas we have to consider in when we are going for bending or drawing operations. See, in cutting operations, the sketch we can see that metal strip, die relief angle, punch. Here is a punch is fixed to a punch holder, then a die, a cutting head, a stripper, a fastening bolt, etc. Now let us see list of operations for cutting holes. List of operations for cutting holes are punching, slotting, and perforating. First, let us see what is punching. Punching means when cutting a hole or when holes are cut in a blank, the operation is called as punching. When holes and small hole is cut in a blank, then we call this operation as a punching. The punching plays an important role in the production of sheet metal stamping. Punching plays a very important role in production of sheet metal stamping. Now let us see what is piercing. There is a small difference between punching and piercing. Now let us see what is piercing. A piercing is a process of making a hole in a piece of part. The piercing is nearly always completed by blanking operation before or after or at the same time. Now let us compare between punching and piercing. In punching involves a cutting a clear hole which results slag, whereas in piercing operation it is produced by tearing action. It is important. It is clear. the hole is produced by tearing operation, not by cutting operation. This is the difference between punching and piercing. Now let us see what is the difference between blanking and piercing. Okay. In blanking is a process of producing a flat component, whereas in piercing is produced by tearing action or not by a cutting operation. The cutout in blanking operation, the cutout piece is called as blank. Sorry, the cutout piece is a useful product, whereas in piercing it is a scrap. In blanking operation, the clearance is given in the punch, whereas in piercing operation, the clearance is given in the die. In blanking operation, the die size is equal to the component size, whereas in piercing, the punch size should be equal to the component size. Here I would like to say that the clearance also, but later I will discuss about the clearance part here. In this diagram, you can see that in piercing tool, we have got land clearance and a draft portion is called as angular clearance. So we'll discuss in later. Now let us discuss what are the operations involved for size controlling. These are the list of operations which is involved for, which is used for controlling the sizes. That is trimming, slitting, and shaving. Now, what is trimming? A trimming is a process of removing excess metal which remains around the parting line, whereas it is used for dies, casting, forging, and sheet metal drawing. Okay. What is the purpose of trimming? During the drawing of sheet metal into a cup, excess metal is left on the flange or at the top edge of the cup. So when a cup is being drawn, there may be excess material which will be in an irregular shape on it. So that excess material should be removed to finish the cup. For this operation, we remove these excess material. For this removal of excess material is called as trimming. The cutting off the excess or damaged metal after drawing operation is called as trimming. Okay, now let us see the operations for progressive working. The operations for progressive working. It comes under notching, semi-notching, lancing, parting off. These are all comes under the operations which are involved for progressive work. What is notching? Notching is the operation from removing a piece of scrap metal from the edge of the strip. That is, removing a small portion of material from the edge of the strip is called as notching. Notching is normally done to shape the outer contour of the workpiece in a progressive die. It is also removes excess metal before drawing or forming operation in a progressive die. So notching is used for removing excess metal before drawing or forming operation in a progressive die. Now let us see, what do you mean by semi-notching? It is an operation of cutting a small amount of material from the center portion of the progressive strip is called as semi-notching. So when we remove the metal from the edges, we call it as a notching operation, and when small amount of metal is removed from the middle of the strip, then we call it as notching process. Next, we see about what is lancing. Lancing, so you can see that the material is cut in the 3 sides and is bent in the 4th side, as shown in the diagram. You can see that. In lancing, when metal is cut part way through, no scrap is being freed from the strip. See here, on 4 sides, 3 sides material is cut and 4th side is bent. This operation is called as lancing. The punch is designed in just a way to cut 2 or 3 sides and bend along the 4th side. This operation is called as lancing. In lancing, design is very important. Punch is designed in just a way to cut 2 or 3 sides and to bend on the 4th side. You can note that in this is a combined operation of cutting and non-cutting operation. Here, lancing is combined with bending and for cutting operation. So it cuts along the three sides and fourth side it bends. So it's cutting and non-cutting operations are involved in lancing. A suitable example for lancing is we can see that mosquito coil stand, which we keep it as mosquito coil stand. So it is one of the suitable example for lancing operation. Now let us discuss about perforating. It is a very important operation. See, in most of the places we have a decorative purpose. For decorative purpose, sheet metal, more number of holes will be produced. And this type of operation is called as perforating. For some product required many holes which may be punched in a specific applications. The hole may be decorative one or needed for the passage for liquid or gas or liquid to flow. So in normally you can see in the wash basin we have a small plate which have different more number of holes. Then this is also suitable for perforating operation. When many holes are punched, the operation is called as perforating. When we make one hole, we call this punching or piercing. But when we make many holes or punched, then this operation is called as perforating. The punch used for this operations are called as perforators. The punch which you are using for this operation is called as perforators. Now it's very important to see again the cutting operation. First I told you blanking, shearing on. Now let us see what is the shearing. In shearing operation, cutting must be along straight line. The cutting should be done along the straight line. Shearing is a cutting material without producing strip. Shearing is nothing but a cutting operation which removes the material without producing strip or scrap. And what is the purpose of shearing? Why is shearing is that? Normally, the coils are the sheet blanks will be in a coil form. So the coil cannot be directly used for all the applications. So it should be cut into a required blanks, into large number of blanks. So these coils are cut in a narrow strips when we use for low volume of productions. And square and large sheets are produced for accurate blanks. Then it is used for cutting a straight line. When a metal is cut in a straight line, then we call it as a shearing. Cut into two parts, no scrap is produced. When we cut, for example, when we are cutting a paper, just we cut it, it called shear two, it's separated into two pieces. Let us see what are the advantages of shearing. Shearing is more economical one. Cost of the die is very less. Cost of the die is very less. Where do we use this shearing operation? Shearing is used for producing blanks of variety of straight shapes. Shearing is used for producing blanks of variety of straight shapes. Angular straight line cut are possible. So it can be cut in 90 degree, or it can be cut in a 45 degree, or it can be cut into a triangle shape also. So that cut will be in a straight line, whether it may be vertical or it may be inclined. The blank shapes which can be produced by shearing. Next, we'll go to the operation which is called as bending operation. We are coming here under non-cutting operations. Bending operations are coming under non-cutting operations. In bending operation, what is bending? Bending is defined as shaping the metal around straight axis which extends completely across the material. How can we classify this shaping operation? This shaping can be classified based on the metal flow. Based on the metal flow, the shaping operations are generally divided into three groups. They are bending, forming, and drawing. What are the various types of bending dies? We call V bending die, a channel bending die, a ring bending die, a tube bending die, a curling die, and wiping dies. So there are so many types of dies in bending. Now let us see how while bending, normally when metal is bent, there are two types of stress takes place. One is tensile stress and another one is compressive stress. During bending, the inner surface of the the inner surface of the component tends to reduce its length. While bending, when we bend the metal, what happens? The inner surface get reduced, outer side expands. So therefore, the fiber are under the compressive stress. The inner surface is compressive stress are developed you should know that the wrinkling will take place only on the inner surface of the bend. Wrinkling will not take place in the outer surface. You can see a small folder which is called as wrinkling. While we are bent, the wrinkling takes place on the inner surface of the while bending. Okay. Wrinkling takes place only in the inner surface. It does not experience since we have a compressive stress. Whereas in the outer region, we have a tensile stress. Okay. While bending, we should calculate the bend radius. Now let us see what is bend radius. A bend radius is a minimum radius to which a plank can be bent without cracking. Try to understand that bend radius. The bend radius is the minimum radius to which a blank can be bent without cracking. What are the factors that are influence the bend radius? The factors that influence the bend radius are angle of bend, length of bend, material properties, direction of bend in relation to the grain structures. So these are the types of bend can be taken into. While bending, these factors should be considered for bending radius. Now let us see what is neutral axis while bending and neutral axis. In sheet metal, the sheet metal is stressed in tension on the one surface and in compression on the other surface. At certain line, therefore the stress are zero. At certain line, the stress is zero. The line of zero is stress is called as neutral axis. The line below that line, we have a compression stress. Above that line, we have a tensile stress. At one particular line, stress is equal to zero. When the stress is equal to zero, then this line is called as neutral axis. What are the characteristics of neutral axis? The sheet metal thickness is constant as the radius bend is decreased. Okay, if the sheet metal thickness is constant as the radius of bend is decreased, the neutral axis shift closer to the inside surface. If the radius of bend is constant, the sheet metal thickness is increased. The neutral axis shift closer to the inside surface. If the radius of bend and the sheet metal thickness are constant, the degree of bend increases. The neutral axis shifts closer and closer to the inside. Since I am unable to show that particular diagram here, but anyhow, I thought I would have explained you about the neutral axis and types of bending in a bending. Now let us see about the edge bending. Edge bending. Edge bending, as shown in the figure, it is a cantilever of bending operation in which a punch forces the metal over the edge of the supporting die. A spring or loaded pad clamps the sheet against the die block before the punch contracts it to prevent it from being improved during the punch travel. There are still so many depths. Just I want to just brief about only the fundamentals of it. Okay. Now let us see about the press working terminology. Let us see about what are the terminologies about. First, bed. It is a very important part of the press tool. Okay. Bed is the lowest mode part of the press. It acts as a table on which a bolster plate is mounted. Over this bolster plate, we are going to mount the die set, which consists of, okay. Now, what is a bolster plate? See, frequently in our own particular press, frequently we will be changing the dies, different types of dies. For example, blanking die, then pacing die, then we go for progressive die, then for compound die. Depends upon the operation, we may load and unload frequently we may load and unload the press dies. So once due to frequent changing in it, the wear and tear may created will damage the bed. So to change the bed, the cost will be very higher. In order to avoid this, we use a bolster plate. This plate is normally placed over the bed, and over this bed, this plate only we are going to keep our die set. So in case if it's worn out, this particular plate can be removed and we can replace the new plate. The cost wise is very cheaper when compared with the replacing our bed. The bolster plate is nothing but a thick plate. It's normally made out of boiler plate. The thickness of the plate may range from 50 to 150 mm thicker. Over this plate only we are going to see about the die holder. Before I am going into this die holder part, I would like to explain about the basic fundamentals of cutting clearance. Very, very important. A cutting clearance is a international dimensional gap between the punch cutting edge and the die cutting edge. Cutting clearance is very, very important. A cutting clearance is the international dimensional gap between the punch cutting edge and the die cutting edge. When punch enters into the die, it is called as cutting clearance. When punch enters into the die, it is called as cutting clearance. The clearance is always expand as the amount of clearance per side. Clearance is always expressed amount of clearance per side. In press tool, we give clearance only per side. For example, 3 mm clearance is given, then it indicates that 3 mm clearance per side. Then the total clearance, it is 3 plus 3 on two sides, we consider as 6 mm. So clearance, we always consider clearance per side. Amount of clearance, how do you, amount of clearance depends on the type of the kind of thickness of the material, hardness of the material. So it depends upon the what kind of material, thickness of the material and hardness of the material. Based on this, we will consider the clearance part. But normally we give 3 mm, it is equal to the sheet metal thickness. Minimum it should be 3 mm, 3 mm clearance. Okay. Let's, what are types of cutting clearance? There are different types of cutting clearance, very, very important. One is optimum cutting clearance, excessive cutting clearance, insufficient cutting clearance, and misalignment of punch and die. What is optimum cutting clearance? When cutting clearance is optimum, a small edge radius will be formed. Small edge radius will be formed. The edge radius is a result of plastic deformation during the first stage of the shear action. First action of the shear. See, there is a punch enters into the, as shown in the diagram. See, the punch enters into the die. A blank is cut. So in this particular position, clearance part is very, very important. Just I want to brief about it here. Then the second stage of shearing action results in high burnished band. This band is called as cut band. The thickness of the band should be equal to 1/3 of the sheet metal thickness. The thickness of the band should be equal to 1/3 of the sheet metal thickness. The remaining 2/3 portion of the cut is called as break. 1/3 of the sheet metal thickness is called as band, thickness of the band, and the remaining 2/3 portion of the cut band thickness of the material is called as break. It's called as break. Always the dimension of press working component is measured along the cut band. So note, it's very, very important. Note that always the dimension of press work component is measured only along the cut band. In case if the cutting clearance is excessive, then what happens? If the gap between the punch and die is more, therefore the edge radius becomes larger. In case by mistake or by frequent use on it, maybe the punch and there may be a gap between the punch and die may be increased. In this cases, the edge radius becomes larger. Therefore, it does not bend smoothly with the cut band. It does not bend smoothly with the cut band. The cut band becomes smaller. The break shows the irregularities. Heavier burr are noticeable along the cut contour. The burr results from dragging of material. By seeing that, experienced operator or the worker or the supervisor may say that we are the excess cutting clearance is excessive. By seeing the burr result, by burr formation, he may, on his experience, he can say that it is due to excessive cutting clearance. In case if the cutting clearance is less, insufficient cutting clearance, then what happens? That is, a gap between the punch and die is less. Therefore, the width of the band will be more. Therefore, if the gap between the punch and die is less, therefore the width of the band will be more. If the cutting clearance is too little, 2 or more cut band will be formed. If the cutting clearance is very, very less, then the cut band may be 2 or 3 cut bands will be formed. Smaller clearance causes a greater punch and die wear. Smaller clearance normally causes a greater punch and die wear due to the additional burnish of the metal stick to the punch and the die. Okay. What is the result of excessive die clearance? Excessive die clearance allows a large edge radius and excessive plastic deformations. In case of blanking operation, where should I give clearance? Okay, it's very important. In case it is a blanking operation, then in this case, where should I give a clearance? In blanking operation, the cutout piece is important. Cutout piece is important. Therefore, the die should be given exact size. The die should be made to the exact size. The die clearance is given in the, so the clearance is given in the press. The die size is equal to component size. The die size is equal to component size. Try to understand that always the die should be bigger than the punch. So that in this case, when the die is equal to component, we give clearance in the punch. Then means in punch, whether it should be added or reduced. The clearance should be minus from the original size. So punch size is reduced. In the punch, clearance is given the punch, that is in the minus, we have to subtract that. In die size is equal to component size. Okay. In clearance, we have got similarly land and angular clearance. First, what is land? In the die portion, in the die. Now let us see what is die. Die is also called as a retainer, a die shoe. It is used to hold the die block in a proper alignment with the punch. It is mounted on the bottle plate. Okay. In the die portion, we got straight, the narrow cutting land. It is called as land. The narrow cutting space left below the cutting edge is called as land. What is the main purpose of land? The main purpose of land, the main purpose of the land and the die set is the width, allow the material for grinding to the face of the die during periodical sharpening. Small, so we have to sharpen it. So for that, a regraining process, a buffer of 3 mm should be kept. What will be the size of the land? Up to 3 mm, normally we give up to 3 mm. Sheet metal thickness is equal to 3 mm, land is provided. In case if thickness of material is more, for example, sheet metal, for example, we have 4 mm thick or 5 mm thick, then the land should be equal to thickness of the paper, thickness of the material. Therefore, thickness of the material is equal to thickness of the land in case it exceeds more than the 3 mm. Why do we give, what is angular clearance? What is angular clearance? You can see that a small taper has been provided in the die part. See, you can see that a small taper has been provided. This angle, this shaft is meant for frequent. The small amount of slope is provided between the die opening to prevent the blank parts or slug from stacking inside the entire, is commonly referred as an angular clearance. Angular clearance expressed in degree per side. Normally give 1.5 degree taper. So it is in order to make this gap helps to fall the component freely after the piercing, after blanking. The component rejected scrap or the required component should come through the drop through die. In drop through die, the punch will be have a hole in it. It has to come. In case if you having straight clearance, then it may get stuck up. If the damage is spoil the die. Instead of that, for free falling also, we provide an angular clearance. Angular clearance necessary to prevent back pressure caused by the blank or slag. Now let us see about the what is the die part, die blocker. It is the female part of the die set. It is nothing but it's a female part of the die set into which the punch slides in it. Opening suit the punch. It is made out of, or normally die block is made out of high carbon, high chromium die steel. High carbon, high chromium die steel material is used for making die alone. The die is provided with a relief angle or draft about 0.75 degree so that the cut piece fall freely through the die. Already I told you that we have to provide a draft, that angular clearance. The draft is provided for free falling of the material. Now let's see what is stipper. It is very, very important. Stipper is very, very important. Stippers are used to prevent the sheet metal from coming up with the punch when it returns after the working stroke. See, in punch, in a die set assembly, the punch descends inside. So stipper, the metal stipper is kept in between the punch and the die. So when the punch moves downward, it touches the sheet metal and it enters into cutting operation takes place. Once the cutting operation is over, whether it may be a required product or a slag. So the after operation is completed, the punch moves upward. While lifting, due to this pressure, it may pulls that material also. To prevent that sheet metal coming out with the punch, a stipper is used. There are two types of stippers. They are fixed stipper and spring loaded stipper. They may also be used. Next, we will see the stock guide and packing. It is very, very important. This is ensured during the feeding between the each operation. Once first operation over, it again the stock metal goes for the second operation. So that should be a proper guide to ensure that accurate location for each successive component. In case if there is not, if it is not, we don't have any stock guide or packing material, what happens, it will shift and it may damage the component size, or it will shift, it may damage the punches, etc. The stop blocks or pilot are often used to ensure after each operation the strip is moved through the correct distance and located properly for the next operation. It's very, very important. Next, let's see about punch. It is a very, very important one. Punch belongs to a male part. It is punch is fixed to the punch holder. Punch holder is fixed to top plate. Top plate is fixed to the shank. The punch size normally depends upon based upon the operation, whether blanking or piercing. In blanking operation, the clearance is given in the punch, whereas in the piercing operation, punch is made to the correct size. And the clearance, always note down that always the punch should be, the die size should be larger than the punch size. So in piercing operation, clearance is given the die. Therefore, component size plus clearance. When we add it, you will get that dimension will be given the die. The punch is made with correct size. So punch plays an important role. The punch may be, it may be fixed in the reverse inverted also. Sometimes the punch may be in the die also, it may be fixed in. Okay, depends upon the operation, it may varies. Okay, in compound die, facing punch, blanking punch, facing die. It is attached to the ram through suitable punch holder and fastened to the device depending upon its design. Next, punch retainer or punch pad. The punch retainer or punch pad is used for holding the punch in proper relative positions. It may be bolted to the punch holder. It is all made of. Now, a pressure plate. It is very, very important. Pressure plate. It is also called as backup plate. Pressure plate is also called as backup plate, which is normally provided between the punch and punch holder. So it is not, pressure plate is placed between the punch and punch holder in order to provide some cushioning effect. This pressure plate is used to give a cushioning effect. It distributes the pressure over the wide area of the punch holder to reducing any possibility of it getting crushed under a heavy load. So the punch should not get damaged. So in order to prevent that, we use a pressure plate. This pressure plate is also called as backup plate. Pressure plate is also called as backup plate, and this plate is placed in between the punch and the punch holder. Next we see about, so these are the basic fundamentals about the press tools in it. Okay, and there are a lot of details to be discussed, and we will discuss in the further classes. Thank you a lot. Thank you.